All right, so 106, we've got an airplane flying. It's going to drop a box while it's flying at 540 miles per hour. So that box is going to fall, but it's going to be moving forward at the same time. It's going to etch out a parabola as it falls. The question is, how far away from where the box was released horizontally, how far away does it fall? They've given us a formula to figure it out. Now I've taken one more step, and I've taken the square root here, so it's just solved for x. We have several variables that we're probably not used to seeing, and honestly, some of them are used in kind of a strange way. So let's look at the variables, make sure we understand what each piece does. X is going to be the horizontal distance, and I'll come back and explain my drawing and where the points go in a second. X is the horizontal distance. That's ultimately what we're trying to find. Y is the vertical distance the box is going to travel. V is the initial velocity, but it's in feet per second, so that's going to take a little bit of work because they gave us miles per hour. And then S is initial height. I have no clue why they used S. Usually it's H, because that makes sense for height. But that's what they told us to go with, so we're going to use S for initial height. I'm going to start with the miles per hour conversion. So 540 miles per hour. We want to get that to feet per second because it says our velocity is in feet per second. So our unit conversion table, a mile is 5,280 feet. Let's get rid of miles. And instead of hours, I want to be in seconds. So instead of hours on top, seconds on the bottom, 1 hour is 3,600 seconds. If you need to go minutes first, then seconds, you can. I like to just jump straight to seconds, but that works. And if you work all this out, you're going to end up with 792 feet per second. So we've got a velocity, that's our V. And we'll talk about how to get all these other pieces now. So let me start putting in what I know for V. 792 squared. And it's going to be over -16. It really doesn't matter where I put the negative, as long as it gets in there. All right, y minus s. So what I did was I made a vertex where the box was dropped, called that 0, 0. Completely arbitrary, but as long as everything is relative to the vertex, you can make this 30,000 if you want. You can make that x whatever you want, but it's easier if you just make that 0, 0. The box is going to travel some distance x, but the plane was 30,000 feet in the air, so I know if it started here, it fell 30,000 feet, so negative 30,000. If you make this positive 30,000, make this 0, it's all going to check out in the end, so it really doesn't matter. All right, the next thing is the y coordinate. So down here, this is the final result. I want to see how far it traveled horizontally, and then this will be how far it traveled vertically. But we do know it fell 30,000 feet, so negative 30,000. Now that negative is really important there. This term's going to be negative. That's going to be negative to give me a positive number, take the square root of. Otherwise, it's complex, and it's not something we can even see in the real world. All right, minus s. S again was the height, the initial height of the object. And for my labeling system, I'm calling it 0. So we'll put that in. You get 34,294.6 feet. I did leave off all the units inside the square root, but if you went through all that, feet per second, this would be feet. Yeah, anyway, it would cancel out, I promise. So you would end up with feet, and that is your distance traveled.